Okay. Hello and welcome everyone. Today we talk about WireGuard protocol, how to set up a VPN with it and forward all the traffic through it using nftables and built-in routing. Everything will be done on Guix and Guix system. So I'm Andrew Tropin. I get some fun out of computing and do a lot of free and open source software development along the way. And I would like to share some part of this process with you and share my recent findings and recent experience with WireGuard. So let's start with a quick introduction to VPN. Basically, you create from the user point of view, it just looks like another interface, which is not real, not attached to any hardware, but just virtual network interface, and you can route all the traffic through this interface or part of the traffic, and it will go to the remote server via some protocol, UDP, TCP, or whatever. It depends on VPN tunnel implementation, and the host on the other end will have another virtual device and will process this traffic, somehow will route it to some other place or something like this. So you basically have tune interface on your local machine and tune interface on remote machine. And this connection is done through the software. It's not everything is encapsulated in this tunnel, but for a user it looks like a basic network interface. So let's go to the WireGuard site. For people who are not very familiar with it, it's quite recent, probably one of the most modern VPN implementations. It uses quite good cryptography. It's fast, it uses UDP protocol by default, and it's very simple. We will open a quick start. Here you can find demos and you can look at them, but basically it is the recap of what is written here. WireGuard is built in Linux, probably since I don't know which version, but for a few years already. So on most recent Linux desktops or servers, you can just create a VPN interface using this command. But because we have Guix, we will do another thing. We will be configuring our VPN declaratively. And for this, we will need a Guix documentation. Let me see, for example, this one. And let's open okay. Now let's open this one and let's try to find WireGuard. Here, on Guix system, we have a WireGuard service type. Actually, for more details about VPN and WireGuard itself, I probably already have a stream where I configured WireGuard on nix-os. You can watch it. Probably you will find much more details. Today I will be focusing more on configuring it on Guix, and the entry point will be the WireGuard service type. Basically, WireGuard is more distributed protocol than usual VPN protocols. So you can have a few different peers which can connect with each other, and it's up to peer to configure how it interacts with other peers. Basically, you have two keys, the private key and the public key. You have your private key on your machine, on your peer, and you share your public key with other peers. And the same will be done by other peers, so you can exchange encrypted messages. How you exchange those private and public keys depends on you and your use case. Basically, I just generate a key and share this key with my other host, and I do it on my local machine. Let's do it. WireGuard basics, creating keys. So for this, I will need a terminal. Inside this terminal, I will need WireGuard tools. I will create a VG directory. We'll go to this directory and we'll call VG with some arguments. Basically, it has not so much comments, and one of them is gen key, and it will just create a private key. Local key. Let's call it local key. And if you take a look, you will see some small string with alphanumeric characters. Out of this private key, you can get a public key using VG pub key. And this is your public key. You also can generate a key for your server, for example, like this. And of course, you can obtain a public key for the server like this. You will need those keys to configure to peers. That's basically it. It is used to establish encrypted connection and encrypt all your traffic going through the VPN tunnel. And the last thing that you need for configuring peer is setting up allowed IPs and endpoint. Here I configure, I will show my real configuration, which I use for myself. I configure WireGuard service type. I run it on this arbitrary port. I allow those addresses. I set those addresses for the virtual interface. So if I connect to my remote host and we'll take a look at WireGuard interface, you will see that I have this IP address and this IP address that I specified here. I generated a random IPv6 address and like almost random IPv4 address. I will be using addresses from this from the nearest subnet for my WireGuard peer. And here you can see that I list one peer for my server, and it will be my laptop. I call it Guix, and public key of my laptop is following, and allowed IPs for it listed here. It's different from the one I use for the interface itself, of course. And also I specify the private key, and I copy it to the private key for the server to using SSH. I generated on my laptop, and after that I moved it to the server. That's it. The same way you can configure it on your laptop, but I didn't done it declaratively. I have a script which sets up a connection, and I will explain why I do it with a script. But before going further, I will explain a few more details about server configuration. When we established a VPN tunnel, everything is good, but no traffic will go to the to this tunnel. So we will be interacting with our internet as usual. To make traffic from my laptop go through the VPN tunnel to the server, I need to set up a routing. I will show it a little bit later, to route all the traffic through the tunnel. And also on the server side, I need to set up a NAT. Here I made a basic NAT for IPv4 using nftables, and I did it declaratively with nftables service type like this. I will share a link later to this config, probably in the description of the stream. And also we need to allow IPv4 and IPv6 forwarding. So let's check that. We can see that the values are correct. So the forwarding is allowed by the kernel, and we have NFT configured. So nftables list, I guess. Or show. Okay. Show me what I can do here. NFT. We can see that all the rules are here, already deployed on my server. I basically deploy that config using Guix deploy. You can find, you will be able to find this target here. And one more tricky thing that I already have a base service configuration which contains a lot of services here, and I use modify services macro which takes this list, and if there's a sysctl service type, we take the config and we inherit from it and override settings using this construction, which appends to default sysctl settings this value. And you can see here the default settings is FS protected hard links and protected symlinks. And if we evaluate this definition, okay, we won't be evaluated like this, but we can evaluate this one. Okay, for some reason it don't want to evaluate this expression. It's very strange. Probably something wrong with the REPL or the geyser. But overall, we checked it on the server that this configuration is applied, and this configuration is here as well. Okay, what we do on the client side? Let me open vgsh script. We do what is written in quick start guide of WireGuard. So we manually do all the things that was written in this definition here. We create a VG0 interface of type WireGuard. We set the address to the one we want, and we set IPv6 address. Also, we add a peer to this WireGuard interface using this command, and also we set a private key to this interface using VG utility from WireGuard tools. So to actually execute the script, I use the following command: WireGuard tools --vgsh. I won't be executing this command right now. but I will copy it to the script, so to make sure that everyone reading the script will know how to run it. Also, I set the public key of the peer and IP addresses that allowed. And here I set wildcard for addresses to make it possible to route all the traffic through this peer. And as an endpoint, I set the IPv4 address I will be using to connect to it. It can be IPv6 address, it can be Yggdrasil address or whatever you want, I2P, Tor, or whatever. But I prefer it to be IPv4 because not all the networks supports IPv6 at the moment. And after that, I set explicitly the route to this host via my VLAN interface. If we take a look, if we take a look at my current network configuration, we will see that my Wi-Fi interface has this IP address, and of course I have a gateway which is the same but a slightly different IP. It has this IP here, and I explicitly said that all the traffic for this host should go through this gateway. That's it. After that, I set it up, set this interface up, and after that, I delete all default routes and set a default route to go through this interface for both IPv6 and IPv4. And one more thing that I usually need to do, sometimes I need to delete a default route for my Yggdrasil network to route all the IPv6 traffic through the VPN tunnel. So sometimes it's necessary. I will write it down, I guess. And of course you need to execute the script with sudo, like this. That's basically it. Now we have VG interface, and we can check VG show. We can see that it is configured. The public key is following. The peer is following. The endpoint is this one, and we connected for some time. Last handshake here, and the amount of traffic forwarded through this tunnel is here. That's basically it. Let's check our routes for IPv4, and let's check our routes for IPv6. You can see here that the default route for the IPv4 interface still present. Let's check our IP address. You can see that it is IPv6 address of my server. Where is my host? IP6A. Here we go. So all the IPv6 traffic is definitely going through the tunnel, and as you can see here, IPv4 traffic also goes through the tunnel. So the priority, despite the fact that we have two default routes here, this one and this one, all the traffic, the priority is here, and all the traffic goes here. But to be more precise, it's better to set a priority manually, probably using metric or something like this, or just remove the original default route. That's basically it. I would like to have a more user-friendly solution for client. For example, adding the interface using network manager or maybe something like that. Maybe I will also would like to have this connection defined declaratively in my configuration of the system, and have a button to enable or disable it. But I still not researched this area because I needed to have it quickly. So I just went through the instruction, wrote the script, and when I need a VPN tunnel, I just launch the script. And when I don't need, I just shut down the interface and restore default routes. So maybe I will need to persist the solution a little bit better. But for the server side, you can see that solution is persisted, and I don't need to change on the anything on the server. So that's it for today. Let's answer the question by Sartor Resartus. You mentioned that WireGuard is more distributed than other VPNs, if I remember correctly. Could you elaborate? Sure. In usual VPNs, you have a VPN server and you have a VPN client, and you have those explicit roles. And on VPN client, you can connect to the VPN server using VPN client software, and you are not the same in this infrastructure. But in WireGuard, everyone is a peer, and everyone is equal, I would say. So, for example, you can connect to the peer 1. Peer 1 can connect to peer 2, and you will have this network working for all the 3 peers if everything is configured correctly. And you can make different topologies, make different network topologies using WireGuard protocol. For usual VPNs, you probably can't do it easily. You will need to set up separate VPN connections and route traffic from one subnetwork to another network, subnetwork, and so on. I hope I answered your question. For example, here, if I don't configure this network address translation, I won't be able to reach the outer world using VPN tunnel. But I also could configure this the different way. I could add another WireGuard peer, and on another WireGuard peer, I could configure this nftable, and I can route the traffic from my laptop to the third peer, but I would be connecting to the second peer using this VPN. But because everyone is here connected in one network, it would be possible. This is about more distributed nature of WireGuard VPN, I would say. Okay, that's it for today. I definitely done it not in 10 minutes, but a little bit more. But I hope it was useful, and maybe you will use it. Anyway, thank you for your attention, and I will see you in a bit. Bye.